Hello and welcome to a lesson on optimizing with non-quadratic equations. Oof. All right, so before we've learned how to optimize with quadratic equations. So we always assign variables, we draw a pretty picture. We are always able to get one equation where we were given information, something about it. So it was like, if the perimeter of this shape is, 200, then that's something that we are given, and then we can create an equation using that the perimeter has to equal whatever. We then can write an equation where we're going to minimize or maximize something. That's what optimizing is all about. And that one is almost always going to have multiple variables in it, multiple letters. And so we're going to have to use the first equation to rewrite the second equation that we're trying to find the min or max of in order to only have one variable, one letter left over. And from there, we figure out domain, intervals that make sense, things like that. And when we had quadratics, we could just use negative b over 2a because we know that that is how you can find a min or max on a quadratic. So now this step is going to change for us, and we're going to use the calc, which is short for calculator. All right, and we're going to have to explore the graph and how we can come up with a good window, and then how we can find the min and max of things with these things that are not quadratic, so we don't have a little shortcut using like negative b over 2a. And then in a couple of years from now, when you're doing calculus, you'll learn how to do all of this with calculus, and you don't need the calculator at all. It'll be great. So let's get started. We have our first one. I don't think it's too crazy difficult. We have find the dimensions of the rectangle with a minimum perimeter if we know its area is 200 square meters, and then we want to say what this least perimeter is. So we're finding dimensions and a perimeter. So first things first, draw a pretty picture. All right, so here we go. Throw some letters in there. So I'm going to let the length be x and the height of this or width be y, and things I know about this. So I know that the area is x times y for a rectangle, and that must equal 200. And then I know that the perimeter, which I'm trying to minimize, is going to be 2x plus 2y, okay? Because we do x plus y plus x plus y, add up all the sides. So these are my two equations. So the first one is that constraint equation where I was given information. They said, hey, the area is this. And then my second equation is the one I'm trying to minimize or maximize. All right, so what we can do is solve this top equation for one of the letters. Okay, so I solved it for x. And then what I can do is substitute that in to the other equation. So I'm going to be able to rewrite this p min equation as 2 times 200 over y plus 2y. And then if we want to, we can clean it up. We don't really need to, but it is easier to type in the calculator if you clean this up a little bit. So I'm going to do the 2 times 200, get 400 over y, and then plus 2y. All right, so this has our variable in the denominator, which means this is a rational equation. It is not a quadratic. All right, so we're going to follow a little three-step process. We're going to graph this thing. Okay, we're going to then hit calc maximize or minimize, whichever one we're trying to do. And then we're going to interpret what that actually means. Interpret. I always feel like there should be an E at the end of interpret. I don't think there is though, but I feel like there should be. So let's jump over to the calculator so that we can try to figure this out. So we're going to go to y equals, and we're going to type in that equation. So 400 over, now I'm going to use x because the calculator can only handle graphing with y's and x's. It doesn't really know how to do like p and y, which is the two letters that we have for this one. So in my calculator, y in the calculator is really my p, my perimeter. And in the calculator, x is actually my y value. So it's a little tricky. You just got to pay attention a little bit. So I got that. Normally we like to hit zoom 6, which is a 10 by 10 window. And you might notice that absolutely nothing shows up, which is just great. So one of the things we could do if we have no idea what this window looks like, okay, is we can hit trace. And if you look down there, it tells us that x equals 0 and y equals nothing. And if we just kind of hit our cursor, you can see I have y values that are like really high up, like multiple thousands up, and then they're going down, 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 down as I go, and they're still going down. So what I'm going to do is adjust my window here uh, to say, hey, let's just let x values go from 0 to 10, because I don't think it makes sense for us to have a negative value here, because remember, our x's and y's over here are side lengths. So it wouldn't make sense for our value to be a negative number. So I'm going to do 0 to 10. And then rather than play around with those y values, I'm going to hit zoom and then number 0, which is zoom fit. Okay, and what that does is it looks at my window for the x value. So I said go between 0 and 10, and it's going to pick y values that look good for that. And it gives me a graph. And this graph, not great, because I don't see a minimum on it. So I'm going to play around a little bit more with this thing. So I'm going to expand this to, let's say 20, because I don't think that I can see enough. And then actually don't think I need that much. If you look at the little graph in the tiny corner, do you see how it's so low on the graph for a long period of time? I think I don't need to see as many high y values. And I'm just going to go down to a perimeter of 0, basically, because remember that this is perimeter we're talking about. I actually think this is going to be aggressive still. I'm going to drop it to 100 and just see what happens. Ooh, okay. So I can start to see where a minimum is. It's going to be in this flat line right here. If we want, we can just increase our x values just a little bit further and we'll be able to see. So I'm just increasing the x values and now I can start to see I'm getting this like swoosh shape that's going on here. And what I want to do is find the minimum value that's right here. So I'm going to hit second and then calculate minimum number 3 here. And then I'm just going to move myself to the right. I just need to make sure I'm off of that flat line, okay? Because the minimum could be anywhere on this flat line that my cursor's on right now. It's just that the screen isn't accurate enough to graph it. So I need to just make sure I'm off that line. So I just go to the left, go to the right, and then I just hit enter and spits out this 14.142 and then 56.8, whatever that is, okay? I guess it's 56.9. So I'm just gonna sketch a little graph of that just so we have it over here. Ooh, that was a rough graph. That is really not what that looks like. All right, a little shaky apparently. And I want to find that. So that was 14.142 and then 56.569. And remember that we graphed that as a y value and a p value. All right. So there's my y value. It asked me to find the dimension, so I need to backtrack and figure out, hey, what was my x value? But remember, x is just 200 divided by that y value. So we can do this in the calculator. One of the really cool things is that when we do anything in this graphing menu up here, this value of x that's right here, it's stored when we're on our home screen. Okay, so when I'm on the home screen, hit that x value, it's going to be that 14.14. So I literally can just do 200 divided by that value that I got, and it just so happens that I get the exact same number here. Okay, so I get a 14 by 14. That is something that happens frequently with rectangles. When we're minimizing or maximizing them, it tends to always just be something that's a square, because a square is a rectangle, in case you forget that. So we can answer our question now. We have, what are the dimensions? So the dimensions are going to be 14.142 feet, meters, whatever it was, by 14.142 meters. So there's our dimensions. And then they asked what that least perimeter is. Well, the calculator spit that out right there for us. Okay, so our P min is just this 56.9. Okay, and it's still just meters, not like meter squared or anything. So there we go. There is our first optimizing one. And it's super similar to what we were doing before with quadratics. It's just that now we're going to use the calculator. All right. So you should pause the video and try the your turn. And then when you unpause it, I will be here and we can go over it together. You totally paused it, right? I know you did. You did. All right. Find two positive numbers such that their product is 192 and the sum of the first plus 3 times the second is a minimum. So I'm going to let these two positive numbers be x and y. So I'm going to say, hey, x times y has to equal 192. And then I'm going to say, hey, x plus 3y is going to be some sort of minimum value here. So here are two equations, one where we know something, it equals 192, and one that we're trying to minimize. Let's do that same idea. I'm going to do x is a 192 over y, and then I'm going to replace it in this equation right here. So my minimum that I'm trying to find is going to be 192 over y plus 3y. And I'm going to jump and graph this in the calculator. So just type that in super quick, 192 divided by x plus 3x. I have no idea what my values for x should be. I love to just start with 0 through 10 because I always feel like that's going to be a good thing. And then I'm going to hit that zoom fit, which is zoom 0. And terrible again. Gosh, it's the worst. So I'm going to play around with it. Some things I'm going to do, I'm going to increase the x values always, and then I'm going to, first time around, I always play with the y values. I think they're just showing me way too many high values. Okay, so I'm going to just drop this down to like, I'm just going to try 150, which might be too much. And I'm going to drop this one down to 0, because remember, this is talking about a minimum value, and I have positive numbers, so I know that it's going to be a positive number here. So when I hit graph, there we go. I'm looking for this like swoosh shape. I'm looking to see a minimum or a maximum on my graph. So I am going to do my min. So second calc number 3, minimum. Hit a little enter, move myself over. Need to get past where I think the smallest one is, which I think was right there. And then enter, enter. It spits out, look at that, exactly 8 and 48. So that was pretty cool. I'm a big fan of just sketching the graph. You know, you don't have to be like the most accurate thing in the world. And then we label what we have going on. So we got 848, which was a y value, and then this minimum value that we were trying to figure out here. All right. So let's see, what are we trying to do? We're trying to find these two positive numbers. So let's figure out what x is. X is going to be 192 divided by this y value that we just found. So I'm going to jump over here, 192 divided by 8, and I get 24. And so those are going to be my two numbers, right? One's 24 and the other is 8. Ta-da! Math. All right. Now we get to this fun problem. We're going to do two different types of this one. So this first one, we actually don't need a calculator. We can solve this one completely without a calculator. And we probably could have done ones like this in the previous unit, but we have this open top box is formed from a rectangular piece of cardboard that is twice as long as it is wide. So I'm going to start off by just labeling things and say, hey, this thing is 2 times as big as it is wide. All right. And then it says that squares of side length 1 are removed from each corner. So each one of these little things is a 1 by 1 little square. And they're folded up. So if you were to take a piece of paper right now and cut squares off in all the corners, you could fold the little tabs that are left over and it creates a 3-dimensional box, such as this right here. And what ends up happening is like this side length of 2x, well, we removed a square length of 1 right here from it and another length of 1 right here from it. So this side length would now be a 2x minus 2 when we fold it up. And the same exact idea is going to happen here and here. This is going to be x minus 2 because we're removing a 1 and a 1 from each side of this thing. And then the little squares, cutouts, they end up becoming the height of this thing. All right, so I get that the dimensions of this box are going to be 2x minus 2, x minus 2, and 1. And we can actually start right here and figure out a domain because this is going to be important for these types of questions, which is that my domain is going to be x has to be bigger than 2. And that's because my side lengths cannot go negative. So if I look at the smaller of my two side lengths, which is the x minus 2, it has to be positive. And so x is going to be greater than 2. If I were to start off with the 2x minus 2 has to be greater than 0, I'm going to get 2x has to be greater than 2, and x has to be greater than 1. And remember, we always use the most restrictive version, which is going to be that x has to be greater than 2. All right? So that's an important thing for us to be able to figure out the domain. That's going to help us when we're doing all of these problems and eliminate things that we don't care about. So if we keep reading, it says, hey, the volume of this box is exactly 112 cubic inches, and we want to find the dimensions of this box. So let's start off. Volume equals, we know that of a 3-dimensional prism like this, it's just length times width times height. And so I'm going to do 1 times 2x minus 2 times x minus 2. And I know that that's going to equal 112 because this is a volume. So let's FOIL things out. I'm going to get 2x squared minus 6x plus 4 equals the 112. And well, I don't know why I put it equals 0 over there. I'm going to just ignore that whole other side now, I think. Yeah. Let's move the 212 to this side of the equation. Okay, so I'm going to get minus 108 equals 0. And then let's divide everything to make our lives easier. So we have x squared minus 3x minus 54. This feels super factorable to me. So I think we'll try to factor it, right? I think we're going to get x minus 9, x plus 6 equals 0, which is going to give me an x equals 9 and an x equals negative 6. And then because we did that domain thing earlier, we can cross off that value because we know that that will not work because of our domain. So to find the dimensions of the box, now that we have this x value, well, these are the dimensions of the box right here. So I have that 1 inch was given to me. Okay, then we're going to do by, and let's do this one first. If I do 9 minus 2, that's going to be 7. Okay, so it's 1 inch by 7 inches by, and now we'll do the same thing here. So that's going to be 2 times 9 minus 2. So that's going to end up being 16. And so here is the dimensions of this open top box. So you should try the incorrectly labeled question here. Oh my gosh, I did both of them wrong. This is the your turn. And I did the example. Oh my gosh, what a bad typo. You're going to have to fire me. All right, you should pause the video. You should try this one yourself, see if you can figure it out. I will be here when you are done. Please try to figure out the domain. That's super important. All right, I know you paused. I know you're ready. Let's look at this thing. So we have a nice square piece of material. We're cutting 9 centimeter squares from each of the corners and folding it up. And they were pretty nice. They actually gave us the picture of what it will look like when it's folded up. And they gave us what the volume is. Our domain for this one is going to be x has to be greater than 18. All right. And that should make sense for a couple of reasons. So one is going to be like visually, let's think about it. If I'm removing 9 centimeters from this side and 9 centimeters from this side, I need my x value to be at least bigger than 18. Otherwise, how would I possibly remove 9 centimeters from each side? It wouldn't work. So it needs to be bigger than 18. We can do the same thing where we look at the side lengths and say they have to be greater than 0. We're going to get x is greater than 18. Cool. So let's set up our equation. We got 144 is our volume, and we know our volume is length times width times height, or whatever order we want to do it in. So I have this. Clean it up a little bit. I'm going to have this, right? So we can write that as something squared. That's nice. I'm going to divide by 9. So that's going to give me a do I want to divide by 9? Let's see. If I didn't have a calculator, which I'm not using one right now, I probably wouldn't divide this right now. What I would do is square root both sides. So I'm going to get a plus or minus 12 equals a 3 times an x minus 18, and now it's no longer squared. You just have to remember that you're square rooting the 9 as well. And now I would do it because this is easier for me to see that that's going to be a 4. And then I'll have x equals 18 plus or minus 4. So that's going to give me x equals 22 and x equals 14. And I can cross off 14 because we already figured out that the domain says that that's not going to work. So I got this 22, and the question is asking me what should the dimensions of this piece of metal be, which is an x by x, and I just got x is 22 centimeters, so 22 centimeters by 22 centimeters. Ta-da! Woohoo! Yay! Awesome! Amazing! Okay. All right. I hope you're having fun. I am. Hopefully you are too. Here's the next type. Open top box. This time we're going to have a different setup. So before we were given what the volume was and what the size of the squares were. And so that's like a little bit easier than what we're about to do. So this one says Amazon's contracted with the USPS to try to design some boxes that are going to be used for fancy dancy drone shipments. And what we're going to do is the same idea. We're going to cut squares out of the corners of a 10-inch by 20-inch piece of cardboard. So what that's saying is that this whole length, okay, that is going to be something like 10, and then this whole length is going to be 20. Okay, so from like start to finish, and then we're removing things that we don't know the size of. So this little x by x here, and we're going to say that this full length here would be 20. All right, and the full length of the other one would be 10. Now, if we think about, just like we did before, we're removing these corners from it. So if this one was 20 originally, we're now actually removing two x's, because I'm going to remove this part and this part from this side, which are both size x. So if it was originally 20, I'm subtracting x twice. Same idea for this one. If it was originally 10, I'm removing 2x again. Same idea. I'm removing this part and this part. So that's going to shrink it from being 10 minus x, whatever that is. So we're going to try to find what size squares we should do in order to maximize the volume of the box, because we want to make the box as big as possible so we can fit as much stuff inside of it. So just like before, we know that whatever the size of the corner is going to end up being the height of our box. So when we fold up this box and make this, three-dimensional, beautiful little thingamabob here, we're going to have x as our height, and then like 10 minus 2x is one of them, and then 20 minus 2x as the other. All right, and if it helps you draw that out every time. So volume x times 10 minus 2x times 20 minus 2x. And we want to figure out our domain right away. So let's think about this. X is one of our side lengths now. So I can actually start off by saying I know that x must be bigger than 0, because if it wasn't, then this vertical height way over here is going to be negative, and that doesn't make a whole lot of sense. Now, same idea as before. If I want to figure out what the domain is, I can basically say like, hey, I know this side has to be greater than 0, which means that 10 is going to be greater than 2x, which means that x is going to be smaller than 5. If I do the same thing over here, I'm going to end up getting something that's not as restrictive. So I'm going to use this 5 right here. So in this type of open top box, it is always going to be 0, which should make a little bit of sense because the volume will equal 0 if x equals 0, because that whole equation will be, times 0 here because of that x right there. And then this 5, it's always going to end up being half of the smaller side. So our small side was 10, so it ends up being that. And it should kind of make sense. I did the domain over here in the orange off to the right there, but I'm removing 2x from each side, so I can't remove something more than what is possible. If I have 10 inches total, I can't remove more than 5 inches from either side. Otherwise, it doesn't work. So we got this. This is a cubic function because we would do x times x times x if we FOIL this all the way out. And so we don't know how to minimize or max cubics without the calculator. So let's jump over to the calculator. Y equals, and we're just going to type this exact equation in. So x times 10 minus 2x times 20 minus 2x. And for my window, this is where this is great that we figured out the domain, because I know that the domain goes from 0 to 5. And then when we hit zoom 0, so zoom fit, remember that it picks y values that work with those x values. So it actually gives me a perfect graph every single time that I use the domain that I found and then hit zoom fit. So we need to find that maximum value right there. And so we're going to hit second calc. This time we'll hit maximum. We need to make sure that we are very clearly past it. It's a little high up, so it's kind of hard to see the cursor up there, but you could always adjust the y value if you wanted to of the y min and get a little guess. And I get this 2.113 and 19245. So let's draw that little picture over here. Big fan of just drawing the little picture. So woo, beautiful. And we had 2.11 something. I forgot what the other number was. 3 by 192.450, blah, 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 blah. All right. And this was x comma v. So I put an x value in. The y value is really the volume. So let's read what the question says. It says, what size squares should be cut from the cardboard to maximize the volume? Well, we found that. That's what x is. So the squares should be this 2.113 inches by 2.113 inches. And that's going to be the answer to this question. And we're done. Now, there are some variations on this question that I want to talk about. because they could ask us other things. So one of them that they could ask us is they could say, hey, what is the max volume? Okay, and that is this number right here. So the max volume would be 192.45 inches cubed. Remember, volume is inches cubed. So that's one possibility. And then another thing that they could ask us is what are the actual dimensions of the box? Okay, so that would be like this 20 minus 2x, 10 minus 2x, and x. And so we need to calculate what that is. But remember, it stores the x value when we go to the home screen. So here is x. So I can literally just do 10 minus 2x, and it's going to give me the other side length, and then 20 minus 2x, and it's going to give me the last side length. Okay? And so these are the three side lengths that make up what we got going on. So we had x was one of the dimensions, 10 minus 2x was one, and 20 minus 2x was one. And so if they asked us what are the dimensions of the box, then you would answer 2.113 inches by 5.774 inches by 15.774 inches. Okay? All right. You should pause the video and try your turn yourself. If you want, I would suggest you draw this little picture that I originally had over here. So like the box with the corners cut out. And you should pause the video, and I will be here when you get back. Oh, hey, did you miss me? I missed you. All right, so let's draw this thing. I never draw this super beautiful, but there's our open top box. We would like fold along these lines right here to create the actual three-dimensional shape. We are removing x and x. One of the sides was originally 18, so it's going to be 18 minus 2x. The other one was originally 12, so it's going to be 12 minus 2x. My domain is going to be 0 to 6. So remember, half of the smaller side length. Volume will be x times 12 minus 2x times 18 minus 2x. And we're going to graph this thing in the calculator. So let's just, I think I can just modify this. So we're going to make that a 12, and we're going to make this an 18. I'm going to go from 0 to 6 and do zoom 0. There's my lovely window. This is what I need to try to find a max of. So I'm going to hit second calc maximum. I appear to be on the left side of it already. I'm going to just move myself to the right side. A little enter, enter, and I get this 2.354 and then the 228.162. All right, so I like to draw a picture. I like to label it so I know what's going on with this stuff. And plus, this is a great way of showing your work so that, when I'm looking at it, I know what you're doing. So they asked us, for the dimensions. So the dimensions are going to be what x is. They're going to be what 12 minus 2x is, and they're going to be what 18 minus 2x is. Those are going to be the dimensions of this box. So let's jump to our home screen. X is going to be one of those dimensions, then 12 minus 2x, and then 18 minus 2x. So these are my three dimensions. And then I'm just going to write them down over here, right? So we got 2.354 inches by 7.292 inches by 13.292 inches, which again, I'm just getting from plugging these guys in using the x value that I found. All right. So I don't think that's too crazy. It's very similar to the first one. It's just that you have to be able to understand this picture and be able to write that volume equation. If you can do that, then you're set. All right. These next ones are a little bit more on the challenging side, I think, just because they're a little bit weirder. They involve area, surface area, and volume. And so one of the first things is I'm going to give you equations for surface area and volume for things. I would expect you to know how to find the area of a circle and a rectangle and a basic triangle. But for something like this, where it is a right circular cylinder, okay, so that's this guy, in case you don't remember, and it has an R and an H as its main thing, I would give you what the volume and surface area equations are. So the volume of one of these lovely things is pi r squared h, so basically the area of the base times the height. The surface area, a little crazier, it's going to be 2 pi r squared plus 2 pi r h. So the 2 pi r squareds, that's going to be the area of the bottom circle and the top circle. Okay, and we have to pay attention to that because a lot of these ones end up not having a top, and so we have to modify this equation a little bit. And then the 2 pi r h, That's going to basically be, if we like unwound this thing, we would have that it would be a circumference if we wrapped it around by a height. And so it's basically a rectangle. So if I do 2 pi r times h, that gives me the area of the sides, which was lateral area, if you don't remember. But that's kind of all besides the point because I'm going to give you those equations. So here we have container, right circular cylinder, no top. All right, so it does not have a top. I'm going to have to modify this part of my surface area. It's not going to be 2 pi r squared. It's just going to be 1 pi r squared because I don't have a top, but I still have the bottom. And that surface area is 3 pi feet squared. So let's write an equation. We have surface area is going to be just pi r squared because we only have the bottom circle plus 2 pi rh. So that's going to be, the area of the sides there. And I know that that has to equal 3 pi. And I'm just going to clean this up right now. So first thing is, I notice everything is a pi. I'm going to divide by pi. So I'm going to get r squared plus 2rh equals 3. And now I have a choice. I can either try to solve for r or I could solve for h. And solving for r, annoying because we have an r squared and an r. So to try to get them to just end up being an r equals at some point, not super fun. So I'm actually going to solve this for h. So first thing I'm going to do is subtract the r squared, and then I will divide by the 2r to get h by itself. Now that we have that equation, we're going to create the equation for what we want to maximize, which is the volume. So our Vmax, volume max, is going to be pi r squared h. There's too many letters there, but luckily for us, we know that h is actually 3 minus r squared over 2r. And if we wanted to, we could simplify this. I don't think that we need to. We just have to be really careful when we type it into the calculator because there's r's in the bottom. There's r squared times r squared on top. It's going to end up being a cubic and r to the third if we were to FOIL and simplify everything. We can't handle this without the calculator. So let's jump over there and I'll show you how to very carefully type this in. So first things first, we can just do pi x squared. That's beautiful. Next, I need to open up a parenthesis, and I'm going to do 3 minus x squared. I'm going to close that parenthesis, so that's just the top part of the fraction. Then I'm going to hit divide, and then I'm going to open a new parenthesis for the bottom. So basically, the way that you can enter this into the calculator without messing up is whenever you have a fraction like this, you're just going to put parentheses around the top, divided by parentheses around the bottom. And this will now not mess me up. Now, window, always the tough part for us to try to figure out. But I'm looking at this thing has a surface area of 3 pi. That's not very big. So I would be really surprised if, honestly, I would be surprised if we had an x value, which is really a radius, that is bigger than 3. It's not possible. It's not going to happen. It's going to be way smaller than this probably, but that's okay. I'll start off with 0 to 3, and I'm going to hit zoom fit and hope that it gives me a window. Now, it did. I can see a max from here, but it also gave me way more stuff than I need. So I'm going to clean this up. Which is that I don't need to see any of those negative values. I'm just going to make this a little bit higher. So I'm just going to have it go up to 5. And that's just going to give me a nicer picture for me to look at when I'm doing this. All right, so let's try to figure out what this maximum is. So second calc max, just like we've been doing all along. Go to the left, go to the right. Are you getting bored of doing that yet? And we get this. Friendly reminder, your calculator isn't as smart as you. That is x equals 1, even though it's writing it as 0.99999. All right, so we got, when we graph this pretty picture here, we got 1, and then we got 3.14159.2, and then it's rounded to 7. I actually think that that's pi. This is 1 comma pi, if we were to be super crazy about this, which is going to be r comma v. So our radius is going to equal 1 when we're doing this, and then our height, well, remember, our height we have defined over here as 3 minus r squared over 2 times r. So that's going to be 2 over 2, which is 1. So we actually have that the radius is 1 and the height is 1. Now, this is super awkward wording when it says, what are the height and the base? I think what they really wanted to say here is what is the height and what is the radius of the base, or what's the diameter of the base, or what's the area of the base. They should have specified probably. If they don't specify, I'm going to assume that they just want the radius because that's the letter I already found, and then my life's easy. So I have that the height of this whole thing is going to be 1 foot, and that the radius of the base is going to also be 1 foot. Okay, if they did ask me things like what is the diameter, remember the diameter is just 2 times the radius, so it would be 2. Or if they asked me like what is the area of the base, it's pi r squared, so I would do pi 1 squared, it would just be pi. Just so happens that that's also the volume, which is just a little coincidence. And there you go. So I want you to try your turn. This is the last one that you got going on here, but I'm going to read it to you first because this one's a little bit different. So it says the combined perimeter of a circle and a square is 16. So people tend to just lose that part when they're doing this one. So the perimeter of a circle, aka circumference, and if you added that to a square, is going to equal 16. And then what we want to do is find what the total minimum area would be of the circle and the square. So pause the video, see if you can figure this one out, and then I will be here when you are ready. Cool, let's get this party started. I have a circle, and I know that it has a radius, and its circumference is 2 pi r. You could also use pi d if you wanted to. I'm going to use pi r. We have a square. Okay, so squares have equal sides all the way around, so its perimeter is just 4x. So what I know is that if I added these two shapes together, or move the whole page to the side apparently, if I added these together, they have to equal 16. So if I do 2 pi r plus 4x, that has to equal 16. And we're going to do the same idea as before. We're going to just try to find one of the variables. And I think I'm just going to solve for x, because I think that's going to be easier in the long run. One thing I see first is I can actually just divide everything by 2, make the equation a little bit easier. And then to get x by itself, I'm going to subtract that pi r and then divide by 2. So there's my x equation. Now, to find this minimum area, okay, so we need to remember the area of a circle, pi r squared, and then the area of a square is just going to be x squared. So I'm going to have pi r squared plus this 8 minus pi r over 2 whole thing squared. That's a little trickier to handle in the calculator, but we're going to figure it out. So let us go and do this fun stuff. And by the way, this actually is a quadratic. We could do this with negative b over 2a if we simplified this a ton, I think. You don't want to, so we're going to use the calculator because they're letting us, but we technically could. Fun fact. So here's my pi r squared plus, I'm going to do my parentheses because I have a fraction, 8 minus pi x, close. I'm going to square that right away. Then I'm going to do divide by, and I don't really need the parentheses here, but divide by 2, and then I'm going to square that as well. Because remember, if we have a fraction that's being squared, the top gets squared and the bottom gets squared. There we go. My window, again, I don't really feel like this is going to be huge. I think 0 to 5 is going to be plenty, and I'll hit my zoom 0. And it is. I can see a minimum that's happening there. That's cool. I'm just going to increase my min a little bit just so that the graph is up a little bit. It's just a little easier for me to calculate, especially because people with older calculators, the x equals like 0.5 that I have here and the y equals 11 is like on the screen and it might be cutting off that part. So you could just like lower your y min and it will let you see things better. So second calc minimum, almost did maximum. That would have messed us up. Go to the left, go to the right. Oh my gosh, we're having so much fun. It's not at all boring after doing it 800 times. And I get this, 1.120199 and 8.966. And I'm worried that I have messed up because that is actually different than what I got in the answer key. Weird. My answer key has 1.556 and 12.44 something or other. So I'm a little curious, where is 1.556? It's not even the right value. Let me just double check what we got going on over here. So I got pi r squared plus 8 minus pi x over 2, and that whole thing is being squared. I mean, this feels right to me. I don't think I've messed anything up, so I'm actually a little curious what's going on here. I'm just going to try something a little different. I'm just going to see if maybe my extra like doing this math here somehow messed me up. I don't think it should, but maybe it did. Divided by, I know that that would just be a divided by 4. and I did plus, and I hit graph, and I'm getting the same thing, I think, 1.556. Yeah, curious. So maybe my answer key's wrong. I don't know. You'll have to yell at me. Oh, hey, leave a comment. Don't forget to like and subscribe. If you actually got the 1.556 that I was expecting to get, because I'm thinking that something's wrong, either the answer key or whatever I'm doing right now, but I just can't see it. So I don't know what's going on here. Um, maybe one of you see it and you're like, you stupid person, come on, you could have just done that and then everything would be right. Oh well, I'm gonna go with this 1.22. So this would be my radius. And I know that the x value is 8 minus pi, that radius, divided by 2. And so I would get this value as my x value, which is also just completely different from what I got, which I guess makes sense in the answer key. So the answer key, I got that x would also have been 1.556, which I think that that's what the right answer is. So I think I've messed up somewhere, and I just don't know where I've messed up right this second. And if we're looking for what the actual question's asking for, it's saying, it didn't even ask us to do this. We were done when we wrote the area function. Why didn't anyone tell me? We could have just stopped right here. But we went through the whole process. So I would say that you would say what the radius is, because that's a good dimension to use, and what a side length is of the square. So what I think the answer should be, according to my answer key, was 1.556 units and 1.556 units for both of them. If we're going off of what I got for whatever reason here, 1.120 for the radius, and then 2.24 for the side length. And yeah, let me know if you actually got the 1.556. And there you go. The rest is practice. Hopefully you listen to this video at like 1.5 speed. Otherwise, this has been a long one, but it was a harder lesson. So we will go over any questions you have. You got the homework right here, 1, 2, 3, 4 questions. You got some extra practice that use some various things if you want to go crazy and practice some of these. And I will catch you in the next one. Okay, bye.